Mixed problems. Why do we have to deal with mixed problems in stoichiometry? Because in stoichiometry, we are not limited to the use of mole and grams as our units, or the amount of substances and mass as our quantities. We can also have volume. So volume is very specific for gas, okay, so or for gases. So in stoichiometry, we only consider gas at STP. Okay, so what is STP? STP is standard temperature and pressure. Now, this standard temperature and pressure has values. So the standard temperature is 273 Kelvin and the standard pressure is 1 atmosphere. Now, so meaning we will only consider gas at standard temperature and pressure. This one has a value equivalent to 1 mole. So what is that? For every 1 mole of gas at STP, there are 22.4 liters. Again, in 1 mole of any gas at STP, there are 22.4 liters. Now, what's another quantity? Another quantity would be particles. Now, we know that particles can be atoms, it can be molecules, or it can be formula units. Now, how will we relate particles to mole? You're very familiar with that, with this. If you are familiar with Avogadro, he gave us the equivalent or the equivalence of particles and mole. So we know that based on Avogadro's constant, 1 mole of any substance is equal to 6.02 times 10 raised to 23 particles. Alright, so that means if you have a substance which is 1 mole and you are looking for number of particles, you use the Avogadro's constant. Alright, so let's have our first problem. The first problem is this. Example number 1. How many liters of nitrogen will be produced from 3.0 grams of ammonia or NH3? So this is our equation. NH3 yields N2 plus H2. Again, you should have a balanced chemical equation. So let's balance. So I will just put 2 here, put 3 here. So we already have a balanced equation. Now let's start with the given. So we have 3.0 grams of NH3. Okay, as previously discussed, we cannot use the mole ratio because we don't have moles as our unit yet. So let's convert grams to moles. Okay, so what do we need to get the relationship between grams and mole? Yes, we need the formula weight. Okay, so for the formula weight of NH3, we count the number of atoms again. So we have N and H. So N, we have 1 atom. H, we have 3 atoms. Then look in your periodic table. What is the atomic weight of these atoms? Okay, so N is 14. 3 is... H is 1. Then you just multiply. So that's 14. H is 3. So you just add. So 17 grams per mole. So meaning the formula weight of NH3 is 17 grams per mole. Now, we're now going to put that in our conversion factor. Alright, so here we have 17 grams of NH3 is to 1 mole of NH3. Alright, now we have another conversion factor here, but this time we can use the mole ratio because our unit is now in moles. Okay, so we will get the mole ratio through the coefficients. So let's get NH3 and the mole ratio between NH3 and nitrogen. Alright, so nitrogen and ammonia. So that would be 2:1. 2:1. So for every 2 moles of NH3, there is 1 mole of N2. Alright? So we now have mole of N2. However, we're not looking for mole of N2. We're looking for liters of nitrogen. So therefore, we know at STP, so we assume that this is at STP. At STP, there are 22.4 liters of gas in 1 mole. Okay, so again, there's 22.4 liters of nitrogen in 1 mole of nitrogen. Alright? So, yan. So, you now have your unit in liters of nitrogen. Okay, so now you encode in your calculator. So, we have, that would be 3 divided by 17 divided by 2 times 22.4. So, the answer is this. 1.97647 dot dot dot. But you have to express into SF only because our given is in 2SF. So the answer is 2.0 liters of N2. So this is our final answer. Alright, so meaning 3.0 grams of ammonia will produce 2.0 liters of nitrogen. Alright, now let's proceed to the second example. So in the equation Al2O3 yields Al plus O2, how many atoms of aluminum will be produced from 8 moles of Al2O3? Okay, so again, we balance the equation. So to balance the equation, we put 2 here, but we put 3 here. Okay, so we now have 6 atoms in both sides of the equation, and we put 4 beside aluminum to finally balance the equation. So again, 2 moles of aluminum will yield 4 moles of aluminum. 2 moles of aluminum oxide will yield 4 moles of aluminum and 3 moles of oxygen. Alright, so let's start with our given. So 8.0 moles of Al2O3. Now, can we use the conversion factor or the mole ratio? Yes, because our unit is already in moles. Okay, so we're going to look for the mole ratio between aluminum and Al2O3, and that is 4:2. 4:2. For every 4 moles of aluminum produced, 2 moles of Al2O3 decomposes. Alright? So there, so you now cancel. Okay? However, we are looking for atoms. So since aluminum is an element, it's already given that aluminum's particles would be atoms. So for every 1 mole of aluminum, how many number of particles or atoms? Yes, we use the Avogadro's constant. So 6.02 times 10 raised to 23. So that would be atoms of aluminum. Alright? So this cancels. So we now have our equation. So in your calculator, you just press 8 times 4 divided by 2 times 6.02 times 10 raised to x 23. Again, so yan. So this should be your input in your calculator. Execute. So the answer is 9.632 times 10 raised to 30 times 10 raised to 24. But you have to express in correct SF. So the answer is 9.6 times 10 raised to 24 atoms of aluminum. Okay, that's it. That's it for mixed problems in stoichiometry.